Good morning, everyone. Our presentation is based on a project titled Real Estate Market Analysis using Stimulated Data, which we have completed as a part of our Statistics for Decision Making course. Our group consists of five members: Mamta Rani, Jashanpreet Kaur, Soni Saluja, Gurpreet Singh, and Gurpreet Singh Suri. We used Microsoft Excel and a random number table to complete our analysis. To begin with our analysis, we needed to create a realistic sample data set. We used each group member's student ID to determine a starting point in a random number table. Each of us selected 50 random property numbers out of 500. We then combined these, removed duplicates, ending up with 50 unique property records. Our final data set included key fields like property price, number of bedrooms, a lot size, which allowed a diverse and unique, useful analysis. In question number one, the sampling method. The sampling method we used was a stratified random sampling technique. This was based on the last three digits of our student IDs. The last two digits gave us the row number, and in the random number table, the third digit from the end gave us the column. This ensured randomness and fairness. In the end, we got a balanced representation of different property types from a pool of 500 stimulated records. Coming up to the next slide, that's question number two. Next, we looked at the frequency of bedrooms and bathrooms in our data set. Bedrooms, most of the homes had three bedrooms, followed by four and then two. Bathrooms, the most common was the two bathrooms and then one and three. We created a bar and pie charts in Excel to make these distribution easier and understand visually. This shows that the most of the properties in our data set are typical middle income family homes with three bedrooms and two bathrooms. In question number three, the type of variable number of stories. Here we have to identify the type of variable for the number of stories a house has. We classified this as a discrete quantitative variable because it can only take whole numbers like 1, 2, or 3. We cannot have 2.5 stories in a standard property. The difference between values and meaningful, for example, 3 stories or more than 2, more taller than 2. In question number 4, we had histogram analysis. Okay, in question number four, we had histogram analysis. We created histograms to visualize the distribution of property prices and interior space. For price, most homes cost between $400,000 and $800,000, and the distribution was fairly symmetrical. For interior space, most homes were between 1,000 and 2,500 square feet, with a slight right skew, meaning there were few larger homes. These histograms help us to spot trends like common price range and typical house sizes. In question number 5, we talked about the descriptive summary. Now we move to descriptive summary statistics for both price and interior space. For price, mean is equal to 642 and 88,000 cents dollars. Median is 636 50 cents $1,000. Our data is nearly symmetrical with a small standard deviation showing moderate price variation. For interior space, mean is 2194 square feet, but the median is higher at 2360. This tells us the data is left skewed. Some small homes pulled the average down. Overall, both price and space data showed a healthy variation and reflected a balanced housing market. Coming to the normally check, to check if the interior space followed a normal distribution, we use three methods, that is histogram. It looks slightly left skewed. The QQ plot, most points were close to line, but some small deviations were seen. And then the three is the Shapiro-Wilk test. The p-value was 0.025, which we reject the assumption of a perfect normality. So while interior space is not perfectly normal, it is reasonably close. In question number 7, it is the confidence interval for price. We calculated a 95% confidence interval to estimate the true average price in the population, wherein mean price is equal to $642,88,000. Standard error was 29.08. The margin error was 58.45. So the confidence interval is from 584.43 thousand dollars to 701 and 33 cents thousand dollars. This tells us with 95% confidence that the average house prices lies within this range. This kind of analysis helps real estate investors to make more accurate pricing decisions. Coming up to question number 8, the confidence interval for interior space. Using the same method, we calculated the confidence interval for interior space. Mean is equal to 2194 square feet. Standard error is equal to 106.94. Margin of error is equal to 213.40. So the range is 1980.96 square feet to 2407.76 square feet. This gives us an estimate for the average size of homes in the market. It helps in planning home designs and construction, obviously. Coming up to question number 9, it's hypothesis test for the price of which is not equal to 1995,000. So, next we did a hypothesis test to check if the average price was different from 1,995,000. It was null hypothesis of 1995,000. Our sample mean was for 642,88,000 again. Test static was 46.49. The p value is approximately equal to 0.00. Since the p value is way below than 0.05, we reject the null hypothesis. This means our data strongly support that property prices are much more affordable than 109,995,000, which is approximately equal to $1 million. Coming up to the conclusion, we had the question number 10 to summarize the most common homes. We have 3 bedrooms and 2 bathrooms. Prices are symmetrically distributed, but home sizes show slight skewness. Our confidence interval gave us reliable estimates of price and size. And finally, our hypothesis testing showed that an average price is significantly lower than a high-end market prices. This project helps us to understand real estate trends and how statistics can make guide market research, investment, planning, and affordability studies. This is all I have for the assignment this time. Thank you so much for listening.